Okay, in this presentation we're going to look at a complex numbers tutorial question. Essentially what we have to do is express this expression here as in standard Cartesian form a plus ib. Now the number is 2 plus I to be cubed, that's the numerator, and on the denominator it's 3 plus 4i to be cubed. So essentially we have a fraction and both the numerator and the denominator are cubes of a very straightforward expression in both cases. So essentially what we have to do is simplify the numerator and denominator separately. My penmanship's not great here. I'm trying to practice with my pen on this, my stylus, but it's getting better. Anyway, so simplify the numerator and denominator separately. Okay, so essentially what we have is this expression to be cubed. So essentially what I'm going to do here is have the individual expression here and then the square of that expression, okay, 2 plus I squared is 4 plus 4i squared, plus 4i plus I squared, and I squared is actually equal to minus 1, okay? So we have 4 plus minus 1, essentially what we end up with is 3 plus 4i, okay? Now the denominator is the same, 3 plus 4i. When we square that, we get 9 plus 24i plus 16i squared. And again, that becomes minus 16. Okay, plus 16i squared. I squared is minus 1, so that becomes minus 16. So essentially what we end up in this case is 9 minus 16 gives us minus 7 plus 24i. Okay. Now, you probably might have spotted this already, and this is why it's sort of working out, it's why it's worth sort of going in the incrementally, sort of baby steps, is that you might notice that this expression here cancels out with this expression here, okay? So essentially what we're left with is this divided by this, okay? So things are much simpler now, okay? So this is straightforward enough. We have, this is our expression again, okay? That's the numerator, the new numerator, and this is the new denominator, okay? So essentially what we're going to do is multiply above and below by the complex conjugate of the denominator. So the complex conjugate of the denominator is minus 7 minus 24i. So essentially it's this expression here. Just change the sign on the complex part, the imaginary part, okay? That's all you do. So essentially what we end up with here is an expression like this. So essentially we just have to multiply it out now. Okay. Let's look at the denominator first. Minus 7. So it's if you multiply a number by its complex conjugate, it's essentially the square of the two, the a and the b. Okay. So a squared is minus 7 squared. B squared is 24 squared. And add them together and we would get minus 7 squared plus 24 squared. That works out to be 49 plus 576. That works out to be 625, which actually turns out to be a real sort of nice number to work with because it's a multiple of 5. Okay. If you detected a little blip there, it's because I just fixed a typo I spotted. I just paused it for a second. Anyway, just moving on. Denominator was 625, and what we're going to do is multiply 2 plus I times minus 7 minus 24i. So let's just look at 2 for a second. Minus 2 times minus 7 gives us minus 14. Let's just keep it 2. 2 times minus 24, that should give us minus 48. That should be a minus there. Another typo I didn't spot. So we have minus there. I'll actually just fix that properly. There we go. Perfect. So plus 1 times minus 7 gives us minus 7i. And plus I minus 24i. And that, again, I there, not 1. I. Plus I times minus 24i gives us minus 24i squared, which is plus 24. So essentially what we have to do is just add everything up now. Minus 14 plus 24, that gives us 10. And minus 7i plus minus 48i, that gives us minus 55i. And again, our denominator is 625. So when we work it out, our the real component of the number we're looking for is 2 over 125, and the imaginary component is minus 11 over 125. So that's our number in the standard Cartesian form there. Okay, we'll leave it there.